Hello. Hello everyone who participated in the symposium. I'm Sang-Yong Park and Song-Shi-On, the presenter of the economic utilization of multiplication differentiation. Look at the table of contents and we will explain. First, multifunctional differentiation in economics. Second, partial differential. Third, an economic problem using partial differentials. Fourth, total differentials. Fifth, an economic problem using total differentials. First content is multifunctional differentiation in economics. In economics, the differentiation of multivariate function plays an important role in various economic models and analysis. Multivariate functions typically consist of multiple variables, and differentials are used to understand and explain the interactions and effects between these variables. First, demand and supply analysis. Second, cost functions and profit optimization. Third, analysis of production functions and productivity. Fourth, consumer theory. The second one is partial differential. Partial differential's definition is identifying the amount of change of the dependent variable when only a specific independent variable moves by one unit among many independent variables. For example, this partial differential y equals 2 times x3 squares times z squares, and then round y divided by round x equals 2 times z square multiplied by round x3 squares divided by round x. So, correct answer is 6 times x square times z square. Then, you can also interpret partial differentials geometrically. If you compute z as a constant in a three-dimensional space, we see that y changes from a1 to a2 or from b1 to b2 depending on x. When you want to know the change or effect of one condition among many different conditions in these economic situations, you can interpret it geometrically by using partial differentials. Next, third content is an economic problem using partial differentials. There is a company that operates for the purpose of making maximum profits. Then there is conditions. First, the total sales revenue and total cost of this company are determined by its output. Second, a company's commodity output is determined by labor and capital inputs. Then, the problem is find the conditions of labor inputs at which the profits of this enterprise are maximized. In order to find the point where the company's profits are maximized, it is necessary to find when the profits are differentiated into labor when it becomes zero, and that is when the profits are maximized. So, we differentiate both sides of the profit function into labor. The equation is 0 equal round pi divided by round L equal round TR divided by round Q multiplied by round Q divided by round L minus round TC divided by round Q multiplied by round Q divided by round L. Here, this equation can be expressed as the difference between MPL multiplied by MR and MC multiplied by MPL, where MPL refers to the change in production when the amount of labor changes by 1 unit, and MR refers to the change in total sales revenue according to the change in production by 1 unit, and MC refers to the change in total cost according to the change in production by 1 unit. In conclusion, the time when this equation using pressure differential is established is when the profit according to the amount of labor input is maximized.
From now on, we are going to talk about the total differential. The total differential represents the total amount of change in the dependent variable changed by several independent variables. If y equals fx is taken as an example here, delta y is divided by delta x and multiplied by delta x. Here, delta y divided by delta x means the change amount of y when x is changed by 1 unit, and delta x means the change amount of x. From the perspective of economics, y can be viewed as the total income of a company or the total expenditure of consumers. If you add x1, x2, x3, x4, etc. as a variable, the delta y is represented in the form of round y divided by round x1 multiplied by delta x1 plus round y divided by round x2 multiplied by delta x2, using the partial differential concept introduced earlier, as you can see in the PPT. Using the concept of multivariate total differential introduced earlier, the change in the size of the production of a company with the following production function will be obtained. The current company has the same production function as the first line's equation. The company is investing 100 units of labor and 64 units of miscellaneous capital. If this company increases labor by 4 units and capital by 9 units, we will take capital output as an example. I'll get this example using the concept of total differential. The change in output will be the sum of the change in output size due to the increase in labor and the change in output size due to the increase in capital. The formula for the sum of changes is 120 over 289, which is the sum of the production function differentiated for L and the value substituted for K. The following concept would be the explanation of the indifference curve. In other words, it is sometimes called the equal utility curve. If this equation is developed, delta U divided by delta Y, that is, the marginal utility divided by delta U divided by Y goods, delta X, that is, the marginal utility for X goods. When analyzed from the perspective of economics, it is the ratio indicating how much the consumption of X goods has a greater impact on the overall utility than the consumption of Y goods. However, since the size of utility here remains constant, consuming one more X materials means how many Y goods should be less consumed to keep the utility constant. In this case, the slope of the straight line is -3. That means consuming one more X material will reduce the consumption of Y material by 3 more to maintain its utility. Now we are going to solve a problem about the indifference curve. The first problem is to formulate the slope of the tangent line. This would be delta y divided by delta x, which means MRSXY. So the formulation would be MRSXY. The second problem is to find out whether the absolute value of the slope of the tangent line is stagnant or felt as you eat more jelly. Looking at the curve, the absolute value of the slope is decreasing as the consumption of jelly increases, so the correct answer would be failing. Thank you for listening to our presentation, and I hope you have a great day today.